Hi everyone, welcome to Numeric Learning. In today's video, let us solve Chapter 2 Polynomials exercise problems from NCERT Exemplar. So the first question for the day is, if one of the zeros of the quadratic polynomial k minus 1 into x square plus kx plus 1 is minus 3, find the value of k. You are given three options. We need to find the value of k in this polynomial. So what are we given? We are given one of the zeros is nothing but we have minus 3. First of all, let us write what is the polynomial p of x. So let the polynomial p of x be k minus 1 into x square plus kx plus 1. This is the given polynomial. And we are given one of the zeros of this p of x is minus 3. What does that mean? If you substitute in place of x, if you put minus 3, then the value of the polynomial becomes 0. That is what it means when the question says that one of the zeros of the polynomial is minus 3. What does it mean? At x equal to minus 3, the value of the polynomial is 0. That is why it's called a 0. Now let us substitute in place of x, we will substitute minus 3 and let us find the value of k. So k minus 1 multiplied by in place of x minus 3. So minus 3 the whole square plus k multiplied by minus 3 plus 1 is equal to 0. So k minus 1 multiplied by minus 3 into minus 3 is plus 9. Minus 3k plus 1 is equal to 0. So multiply 9 with k and 9 with minus 1. So 9 into k is 9k minus 9 minus 3k plus 1 equal to 0. So 9k minus 3k is nothing but 6k. Minus 9 plus 1 is minus 8 is equal to 0. So what are you getting here? 6k equal to 8 or k is equal to 8 by 6. So 2 3s are 6, 2 4s are 8. So what is the value of k? 4 by 3. So the correct answer is A, 4 by 3. Okay. Please pause the video and do it along with me, because one very important thing that every student who is right now starting class 10th is, with respect to mathematics, please make sure you do all the exercise problems of your NCERT and Exemplar, which will give you a very, very good practice. Level 1, the first set of practice that you need conceptually in all the topics within a particular chapter. So please make sure you actually do and see. Please solve each and every question in your NCERT and Exemplar before you start with respect to any other reference book that you have. Right? So here the value of k is 4 by 3. Now let's move on to the next question. The question is, a quadratic polynomial whose zeros are minus 3 and 4 is, you have to find out which one. So whenever you are given the zeros, we can find out the sum of the zeros and we can find out the product of the zeros, right? Because if we have the sum of the zeros and product of the zeros, we know the formula. What is the formula? K multiplied by x square minus sum of the zeros into x plus product of the zeros. So this is your quadratic polynomial. This is your quadratic polynomial which they are asking. Let us find what is the sum of the zeros. So sum of your zeros will be, just add it up. Okay, sum of the zeros. So it's minus 3 plus 4. So what is 4 minus 3? It is just 1. Okay, so this is your S. Let's find the product of the zeros, which is nothing but minus 3 multiplied by 4, which will give you minus 12. Now let us substitute. In place of S, we will substitute 1, and in place of P, which is the product of the 0, we will substitute minus 12. Okay, so what does the polynomial become? It is nothing but k multiplied by x square minus 1 into x plus of minus 12. So I am going to plus into minus is minus. So I am going to write minus 12. Or I'll write a plus and then minus 12, and in the next step I'll make it. So k multiplied by x square minus x minus 12. This is your required polynomial. Right? So when k is equal to 1, you will have x square. But you do not see this as an option, right? X square minus x minus 12. You don't have that. So let us divide throughout by 2. So what do you get? So suppose if k is 1, the polynomial will be x square minus x minus 12. Divide throughout by 2. So what do you get? X square by 2 minus x by 2 minus 12 by 2, which is 6. So this is your required answer. And what is the option? The option is option C. Okay, x square by 2 minus x by 2 minus 6. So always make sure when you have options given, you have to match, right? So the x term also has a negative, the constant also has a negative sign. So that is applicable only in option C. Right? So I hope you understood. Let me know if you have any doubts at all in the comments. And I am also doing a 20 minutes daily practice series. So do check out the playlist Do Math with Me, wherein I solve a set of 5 to 6 questions for a time period of 20 minutes, so that all of you get into the habit of solving problems with me just for 20 minutes a day. Right? So, and also I am hosting a live YouTube session wherein you can connect with me every Sunday 6 p.m. and we will solve important MCQs of all the chapters. So this Sunday, that is April 5, evening 6 p.m. do join me live on YouTube, and we will be doing important MCQ questions from the chapter Polynomials. Right? Do make a note of it, and let's see you all there. Now let's move on to the third question. If the zeros of the quadratic polynomial x square plus a plus 1 into x plus b are 2 and minus 3, then you have to find the values of a and b. Again, let us do it. You are given your polynomial p of x is given to you. X square plus a plus 1 into x plus b. You are given the zeros, right? Now, let's find out the sum of the zeros. Now that you know, so what is the sum of the zeros? Sum of the zeros is nothing but, what is the formula? Alpha plus beta is equal to minus b by a. So what is minus b by a? Minus of a plus 1 divided by 1. Right? Now, suppose if the zeros are already given 2 and minus 3, let us substitute that. So 2 plus of minus 3 should be equal to minus of a plus 1. What is 2 minus 3? It is minus 1 is equal to minus of a plus 1, right? So minus and minus gets cancelled. A will be equal to 1 minus 1, which is 0. So what is the value of a that we are getting? A is nothing but 0. Okay, now with this itself you would have found the answer is option D. But let us do the other part as well. What is the product of the zeros? So let me do it here. With respect to the product of zeros, we know the formula alpha beta is equal to C by A. What is alpha into beta? Just the product of 2 and minus 3, right? So 2 into minus 3 is equal to C by A. What is C? C is nothing but your B, right? A is nothing but your 1. So it is just B. So B is equal to 3 into minus 3 into 2, which is minus 6. So therefore the given answer is A is 0 and your B is nothing but minus 6. So this is your final answer. So which is option D. Okay, very easy. All you have to remember is whenever you are given p of x, first thing is you can pick up the coefficients also. That is, a is 1 here, b is nothing but a plus 1, and your c is nothing but your b. And then use the formula. Sum of the zeros is equal to alpha plus beta equal to minus b by a, and the product of the zero is nothing but c by a. Alpha beta equal to c by a. If these two formulas you know, you can do a lot of things with respect to finding the quadratic polynomial, or finding the zeros, or kind of finding any unknowns like k, which are a part of the polynomial. You can do n number of things if you know zeros, or if you know the sum of zeros. Right? Let's move on to the next question. Fourth one. The number of polynomials that have zeros as -2 and 5 is, so again, let us take the sum of the zeros first. Sum of zeros. You are given zeros, that is alpha is -2, beta is 5. This is given to you. So what is the sum of zeros? -2 plus 5, which is nothing but 3. And what is the product of the zeros? Product of zeros is nothing but, just find the product, -2 multiplied by 5, which is nothing but -10. Now the quadratic polynomial will be k multiplied by x square minus sx plus p. So k multiplied by x square, s is nothing but 3x, and p is nothing but -10. So -10. Now for any value of k, right, suppose if I write k equal to 1, when k equal to 1, the required polynomial will be, you are asked to find the polynomial that have the zeros as -2 and 5. So we found out the sum, we found out the product of the zeros, and using sum and product we were able to generally find out the basic required quadratic polynomial using this formula, right? Now for any k equal to 1, the quadratic polynomial will be x square minus 3x minus 10. Okay. For k equal to 2, suppose k equal to 2, what will it be? 2x square minus 6x minus 20. Correct? Like this, there can be infinite number of polynomials depending on the value of k that can have the zeros as -2 and 5. So based on the value of k, the number of polynomials will be infinite in number, right? So the answer for this question is more than 3. You cannot restrict always, for there can be infinite number of polynomials that can have zeros for any two numbers, not necessarily the given numbers -2 and 5. For any set of zeros, it will never be just one polynomial that has a given numbers as zeros. Okay, you can have infinite number of polynomials with a specific set of zeros that are alpha and beta, that is denoted by alpha and beta. So please remember it. Even if there was an option called infinity, you have to mark it as infinity. So that's your answer for the fourth question. So right now we are doing Exemplar 2.1 question number 4. Let's move on to the next question. I hope you understood. The zeros of the quadratic polynomial x square plus 99x plus 127. The zeros of the polynomial given as x square plus 99x plus 127 are both positive, both negative, one positive, one negative, and both are equal. Let us find it out. Suppose the given polynomial x square plus 99x plus 127 is equal to 0. So, what will be the sum of the zero? Sum of the zeros, which is nothing but your alpha plus beta, will be minus b by a. What is b here? 99, right? The coefficient of x. So minus 99 divided by 1, because your a is 1. So I'm just going to write minus 99. Product of the zeros alpha into beta will be C by A. What is C? 127 by A is 1. So 127. Now, if you have there are two scenarios which are possible. First scenario is if you have alpha plus beta is nothing but minus 99. You can have two scenarios. Either alpha or your beta, they are negative. This is one scenario possible. Or if the sum has to be negative, then I can say both alpha and beta are negative, because if I have, say, minus 100 plus 1, right? Minus 100 plus 1, again beta is positive, alpha is negative, right? Or 1 minus 100, the answer is going to be minus 99. Or if I have, that's the first case, either alpha or beta negative. Or if I have minus 90 minus 9, what is going to be the answer? When both alpha and beta are negative, it is going to be negative. So both alpha and beta are negative. So these are the two scenarios that are possible for the sum to be minus 99. Now let us talk about the product. If alpha multiplied by beta has to be 127, again, there are cases, it could be that alpha and beta are both positive because the product is positive, or even if alpha and beta both are negative, negative into negative is positive. So alpha and beta are negative, both negative. That could also be possible, right? In order to make the product positive, either both are positive or both are negative. Now, among these two scenarios, which is the one condition which is common? See here, both alpha and beta are negative, then your sum will be negative. If both alpha and beta are negative in the second scenario, also the product would be positive. So the correct answer is both alpha and beta are negative. So it's option B, which is the correct answer. So in such questions, you will have to actually take an example and think and do it. So let's see this question. The zeros of the quadratic polynomial x square plus kx plus k, where k is not equal to 0. So about the zeros of this polynomial, the options are: the zeros cannot be both positive, both cannot be negative, they are always unequal, and they are always equal. Okay. So here, if k is not equal to 0, the only possibility is k can either be less than 0 or k will be greater than 0. So let's go ahead and do that. So the given polynomial is x square plus kx plus k. So if it is not equal to 0, k will either be less than 0 or k will be greater than 0, right? If k is less than 0, that means k is negative, then what will be your polynomial? X square minus kx minus k. This will be your polynomial. And if it is k is greater than 0, means k is positive, then the polynomial is x square plus kx plus k, right? These are the only two possibilities. What will be the sum of 0? Alpha plus beta will be equal to minus b by a. So minus of minus k by 1, which is nothing but your just k. And alpha multiplied by beta, product of the zeros, will be c by a. What is c? It is minus k by 1, which is minus k. In the other scenario, wherein k is greater than 0, the sum of the zeros alpha plus beta is equal to minus b by a, which is nothing but minus k. And the product of the zeros will be c by a, which is nothing but just k. Now, in this scenario, right, wherein the sum has to be positive k and the product will be negative k. What does it mean? Alpha, the very first observation is, say, alpha is a bigger number and beta is a smaller number. Okay, so if beta is negative, so bigger number minus smaller number will be a positive number, right? And that same bigger number multiplied by negative of a smaller number will give you negative. So what does it mean? Alpha and beta, they are of opposite signs. They are of opposite sign. If one is positive, the other one is negative, right? So this is one observation. Okay, so if alpha is positive, then your beta will be negative. And if your alpha is negative, then beta will be positive. Okay, so this is the observation. Now let us check when k is greater than 0. Okay, when is the scenario wherein alpha plus beta is minus k and alpha beta is k? That means both alpha and beta are negative, right? Only then the sum will be negative, and if the product of two negative numbers, it is going to be positive. So in this case, you will see that alpha and beta are both negative. Okay, now looking at all the options, okay, the zeros, what do we see here? Alpha and beta are of opposite sign in one of the scenario, and then alpha and beta are both negative. So which of them is the possibility? So it means the zeros of the chord, it cannot be both positive. That's the correct answer. Okay, either one will be positive or one will be negative is one scenario, or both will be negative. Okay, so the answer for this question is A, option A, right? Okay, so the zeros cannot be both positive. In none of the scenarios you are seeing that both are positive, right? Either both are negative or they are of opposite signs. Okay, either both are negative or they are both of opposite signs. So it cannot be both positive. So this is the answer. Let's move on to the seventh question. If the zeros of the quadratic polynomial ax square plus bx plus c, where c is not equal to 0 are equal, then C and A have opposite signs, C and B have opposite signs, C and A have same, and C and B have same signs. So whenever you are given that the zeros or a polynomial p of x have equal zeros or equal roots, right? There is something that you have to remember. So whenever you are given that p of x, they have equal roots or zeros. That means your discriminant capital D is equal to 0. And what is the value for a discriminant? It's b square minus 4ac is equal to 0. Okay, so in our scenario, what is b square equal to? So you'll have b square equal to 4ac, right? ac will go to the other end. What is ac then? ac will be b square divided by 4. Right? What is b square? Any number square is always going to be positive. 4 is also positive. So positive by positive, a and c will also be a positive number. Right? So if a and c are positive, what do you mean by that? A and c have the same sign. A and c have the same sign. Okay. So the option is C and A have the same. So this is the option C is the correct answer. Right? Okay. So the only thing that you have to remember, if in case if the zeros are equal, then you have to remember that discriminant value, that is b square minus d is equal to b square minus 4ac. So that discriminant is 0. Right? Okay. So that's all you have to remember. Whenever the zeros are equal, the discriminant value d is equal to b square minus 4ac. A, b and c, you can get it from here, right? A is your coefficient of x square, coefficient of x and your constant term. Okay, let's move on to the next question. If one of the zeros of a quadratic polynomial of the form x square plus ax plus b is the negative of the other, then it has no linear term and a constant term negative, has no linear term, constant term is positive, can have a linear term but the constant term is negative, can have a linear term but the constant term is positive. So let us do that. What is given is if one of the zeros of the quadratic polynomial is the negative of the other. Suppose if one of the zero is equal to alpha, then your other zero will be minus alpha. Okay. And the standard form of a quadratic polynomial is ax square plus bx plus c. Okay. Always remember this first term, that is x square term, this is what is called as the quadratic term. It is called the quadratic term. Okay. This bx, because it is the coefficient of x and the degree of x is 1. This is what is called a linear term. And c is nothing but it's called a constant term. Okay. Now, we have taken, according to the question, if one of the zero is the negative of the other, that means alpha, the other one is negative of alpha, then what is the quadratic polynomial? The formula is k multiplied by x square minus the sum of zeros into x plus product of the zeros. This is the formula. K multiplied by x square minus just add these two zeros. So minus alpha plus alpha into x plus the product of the zeros, alpha into minus alpha. Okay, so k minus alpha plus alpha will get cancelled. So you'll have x square minus 0. So this entire second term becomes 0. And then you have alpha multiplied by minus alpha, which is minus alpha square. Okay. So what is this x square? As I told you, this is your quadratic term. Okay. So whenever you have one of the zero is alpha, the other one is the negative of that zero, then what happens is we do have the quadratic term. What is this alpha here? What is this alpha square? Do you have any x term? No. Alpha square is a constant term. So the constant term is there, but what is the sign? It is a negative sign. Okay, so you can say that constant term is present, however, but it is negative. But it is negative. So what will be our answer here? Okay, and does it have any linear term? Does it have any x term? No x term. So look at the first option. It has no linear term and the constant term is negative. Okay, so the option would be option A. Okay, the first option. This is the correct option, option A. Okay, I hope you understood. So whenever you do such questions, just be careful about what the question is giving you and understand the question, and please try to do it, and you have to find an inference. You have to observe how the results are looking like. And based on that, you'll have to read all the options and choose the correct one. Let's move on to the next question. Which of the following is not the graph of a quadratic polynomial? So the minute you see, okay, whenever you're given the graph of a quadratic polynomial, see how many times the graph is cutting or touching your x-axis. In this case, it does not touch. So, if it does not touch, the number of zeros is 0. Number of zeros of this p of x is going to be 0, right? Here, it touches it at just 1 point. Again, the number of zeros is 1. Here it touches it at 2 points. So the number of 0 is 2. Always remember, so whenever you have a quadratic polynomial of the form ax square plus bx plus c, this quadratic polynomial will have a maximum of 2 zeros because the degree is 2. It can have no zeros, it can have 1 0, or it can have 2 zeros. It can never go beyond 2. So the first, second and third are quadratic polynomials. But what are you asked? Which of the following is not the graph of a quad? So here if you see the last graph, the number of points where it cuts your x-axis is 3 points. So which means the number of zeros here is 3. And if it is 3, it is never a quadratic polynomial. So the option is, it's the last answer. The last graph is not the graph of a quadratic polynomial because the number of zeros is greater than 2. So it is not a quadratic polynomial. Okay, I hope you understood. Do make a note of this, and we will be solving the exercise 2.2 in the coming videos, and make sure always make it a practice to solve all the exemplar questions and the solved examples of both the books. And do mark in your calendars to join me at 6 p.m. every Sunday in my channel at 6 p.m. for a live session wherein we will be solving MCQ questions. So the coming Sunday we will be doing MCQ questions from the chapter Polynomials. So do not forget, do join, let's learn. Thank you so much for your support. Do share it with your friends and please do subscribe. Happy learning!